Hi, welcome to Kaijo Tutorials. Today you join me on part 2 of the Software to ML 365 challenge. In the last episode we looked at how to actually take the data from a CSV located on the Google Drive and import it and manipulate it. In this episode we'll go a little bit deeper. What we'll do, we'll be able to do comparison of values, like for example age, concentration, etc. Please join me and please like and subscribe. Okay, so let's continue. So if you look at my screen here, I have taken the important bits from the last episode, such as importing the data, setting up PyDrive, importing pandas, also the file, and as you can see here we have access to the file again. So what we're going to do now, we're going to start by doing a few manipulations to get, for example, the average age. We would like to know what's the average age of the patient, what is the oldest, what is the youngest patient that we have. So let's create a next section. So we'll say that in this section we want to calculate the age, average, min, and max. Okay, so we'll say first, so the average patient age. So what we'll say, we'll call HEMA. So we're calling the object that stores the CSV. Then we're going to look for, so if we look here, if we look right here, we'll go for age. So age. Please ensure that you use the same case that is found inside of the video, inside of the CSV, and we'll say we want the mean. Alright, so let's print F, and we'll say average age is, and then we're going to use a bracket, and then we're going to add a variable. Let's print it. Okay, 46.64, etc., etc. I think we would like to have a 2 decimal place at least, or rounded. But first let me zoom in a little bit so the screen is a little clearer. Let me get rid of this and zoom in a little bit. Okay, so what we'll do, the beautiful thing is that there's an inbuilt function in Python 3 that's called round. So say round, I will decide how many places we would like to round. So in our case, we would like to round to 2. So let's see. So the average age is 46.64. Okay, let's look at what is the minimum. Let's start with the maximum age. So who is oldest? So max patient age. So let's just add a round from now, and I want it to round to 2. We'll say HEMA underscore CSV, and we want the age, and we'll say max, and this is a function. We'll print and say oldest patient age, just so that it's a little bit more user friendly than saying max age. Let's see, and the oldest is 99. Interesting. So let's find the youngest. So min patient age. If you notice the way how I name it, I name min, which suggests that I'm going to use the min function, so that a next program will be able to look in and recognize what I'm trying to do. HEMA CSV, and I would like the age, and I would like the min, and round to 2 decimal places. Then we'll print, and we'll say youngest patient age, and then let's see what the youngest patient age is. Wow, from 1 to 99. Okay, now that we have done that, we have warmed ourselves up. Let's go to something a little bit more challenging. Okay, what if we would like to, in data science, one of the things that you have to start out with is a question. So what I'm going to do, I'm going to copy a question. So let's say, so what would like is to find the patients within the healthy range or hemoglobin. Okay, so what is a healthy range for hemoglobin? Well, according to Google, the safe range is for men, it's between 13.2 to 16.6 grams. For female, it is between 11.6 and 15 grams. So let's start with the male. So I'm going to add a note right here so we know what range we're looking at. Okay, so let's call this variable healthy range of, I like to be descriptive, male patients. Let's say HEMA underscore CSV. Then we're going to have to look at when to find the healthy range. We need to look at when the reading and concentration is between, so it is either greater than or equal to 13.2 grams, but less than or equal to 16.6 grams. So in pandas, you can't use and or. You have to use the value. So the value type, I believe it is, don't quote me on that, that means a slash or the and sign. Okay, so HEMA underscore CSV, then we are looking for the hemoglobins. So we like the hemoglobins when they're greater than or equal to 13.2, and we also want, so in math, you know, you add the brackets to indicate that each should be worked out separately first. Okay, we'll now need whether it's less than or equal to 16.6. So the same thing again. So HEMA underscore CSV, and we'll say hemoglobins whenever it is less than or equal to 16.6. Okay, so now that we have this, let's find what the number is. So want to kind of separate the logic a little bit so we can easily retrace our steps. So number of healthy male count. So we're going to just use a len to get the length, and we're going to find the length of the healthy range of male patients. And let's put this in a print statement. So print number of healthy males, and then we will, let's check, and see what's the number of healthy males. Number of healthy males is, according to this, 1,448. Okay, good. And we will also want to see the records. So let's print the results for the records. So print. You could also just place a variable and it will print it. And these are all the records where the hemoglobin levels are between the ranges, in between the ranges. So greater than or equal to 13.2, but less than or equal to 16.6. So now we're going to do the same thing for females. Okay, so let's create another code. And for this one, let's copy the question. For females. Okay, so for this one, the range, as you recall, is the safe range is between 11.6 and 15 grams. So for the interest of time, I'm going to just copy it and make some changes so that the video doesn't go on forever. Okay, so first I'm going to rename these variables. And the beautiful thing about making these variables and making the code, writing the code a specific way, it makes it easier for me to duplicate or make modifications and maintain it. Okay, so all we need to do is change the range. So we'll say for healthy female, instead of 13.2, it needs to be 11.6. And the upper range is 15 grams. So let's see what it says. Okay, and 1962, healthy female. So what if we would like to find the number of healthy males, number of unhealthy males, unhealthy female, meaning they are outside of that range? What we'll do, we'll use a similar logic, but instead of finding in between, we want to find outliers that is beyond the scope. So greater than. So again, if we wanted to make the changes, what we would say is, let's just copy the code for healthy males. And what we're going to do, instead of, so first let me change the names. Unhealthy. Okay, so what I'm going to say here is, instead of greater than or equal, we're going to say the amount of males that's less than 13.2 and greater than 16.6. And that will give me the number of unhealthy males. Okay, did something wrong? Empty. Okay. Also, it's not an. What we'll need to do is say or. So it's either you are below or you're above. You're not in between, so you don't need the and. And the result says 1,861 unhealthy males. Let's copy this again. Let's get the number of unhealthy females. So Okay. So we'll need to change the range again. So this time the lower bound is 11.6, so less than 11.6, and the upper bound should be greater than 15. And we have found 1,347 unhealthy females. And these are the results, some of the results, on a summarized list of the number of the exact records that has unhealthy or outside of the normal range in terms of hemoglobin count. If you wonder what this is on the left, these are those indexes. You can actually remove it. You don't have to let it appear. So what if we would like to find the concentration of, let's first create another code block. What if we would like to find the who has a higher concentration of leukocytes? Okay, so let me copy another question for us to look at. So what we'll say, let's deal with the male first. So we'll say all, we'll call it all male patients. So we'll call HEMA underscore CSV, and we will try to find the male, all the male, and the leukocyte. Then we'll try to find what the sum of leukocyte for the male and leukocytes for female. Let's see something. So let's say HEMA underscore CSV, and we like to find based on the sex when it's equal to M, which indicates male. Then what we'll like to do, we'll like to sum it. So we'd like to get the sum. So what we're going to do, we're going to say total male concentration of leukocyte. How we'll find that is by getting all male patients, then so this is a subgroup showing all just the male, and we'll say who have leukocyte. Let me copy it so that I don't make any mistake. And then what we'll do is sum it, and let's do a test run to see how much do we get. Oh, I'll need to call the variable. So we have 1520.9. Okay, so let's put this inside of a print statement. So print, and we will say total concentration of male total, I'll call it total male of leukocyte. I think I also want to round the results, so let's round it from here. So round to 2 decimal places. Looks a little bit more presentable. Okay. Let's get the average. So to get the average, it's almost the same. So all I'll do, I'll just copy here and say to get the average. Just the only thing that changes really is instead of sum, we'll say mean. And then we'll say mean male concentration of leukocyte. 8.9. So we're going to do the same for female, and as again, in the interest of time, we're going to speed it up by copying what we'll need. We want to work smarter, not harder. Okay. Female. So instead of male, it's female. So total female. Okay, the mean female. Let's test this. Okay, so total concentration 13,318.8, and the mean is 8.5. So the last thing that we're going to do, we're going to try to attempt to find out, okay, which one has a greater concentration. Yes, we can tell by visual looking at it, but let's just write a simple logic, if else, to determine and present to the user who has a greater concentration, meaning the total makeup. So in our last section, what we're going to do, so we're going to say, so we're looking for if it is a male or female that has a highest total concentration of leukocyte. So we're going to just say if total female concentration of leukocyte, if it is greater than total male concentration of leukocyte, then what we're going to do, we're going to print a message. We're going to say the female patients have higher concentration. This is just for practice, so don't take this as scientific data or analysis, as we build up to gradually move to more and more data science and machine learning and so on. Concentration of leukocyte. And let's just show what the reading that we found. So we'll say, we'll add that reading there, and let's round it. So round. Okay, we already rounded it, so that's fine. Okay, else. So if it's not a male, if it's not male, a female that has the higher concentration, then it's a male. So males. So what I will do is just copy this print statement. Let's print and see which one has higher. And so the male has a higher concentration at 15,520.9. So thank you so much for joining me in another episode. And so in the next episode, we'll see what will happen. We'll either continue with this file and do more complex things, or we may move on to another data set to look at some other term. Please join me in this journey. Please like and subscribe, and I'll see you in the next video. Thank you.